like I said, system of equations, the main thing we're talking about is where we have two lines, okay? And we're fighting, your solution is where they intersect. That point in which they intersect, okay? So, if we look at this first column, I'm looking what's in the red right here, okay? So number of solutions, there's exactly one. So they intersect at exactly one place. Okay? Yes. Okay? Now the terminology consistent and independent. I don't really know a really quick, easy way to kind of remember that. I think of it as, first of all, they're consistent because we have an equation that is.
Why is it consistent and independent?
Well, the independent part is independent because I always remember it as independent, they intersect. I try to remember it as independent. If they're independent, they intersect. Okay? They cross at one point. Okay? The consistent part, I hadn't really thought of a way easy to remember that. How is it consistent? Yes, they keep going straight, but that's kind of the same thing with your parallel lines, though. So that's not the main reason why. I guess consistent because they have a solution. Yeah. They're consistent because they have a solution. And then the graph of it, we have two lines and they intersect. Okay, so try to remember that. Now, let's talk about the second one. Infinite. This is, first of all, there's an infinite number of solutions, okay? Infinity, okay? Going on and on. Terminology consistent and dependent, okay? Now, the graph, if you look at that, that's just one line. A lot of the times you'll see, they'll give you like two equations, okay? And they'll say solve, like get in y equals mx plus b form. And a lot of the times you'll see that once you work it out, you'll see that equation, those two equations end up being the same. So essentially, they're infinite. Okay. As we work more with it, you'll catch on a little bit. Okay. I promise it's not as hard as you think it might be. It's fairly simple. Okay. Now, this third one is there is no solution. They do not intersect at all. And they're not on the same line. There's no solution. Okay? And they're inconsistent. Alright? So whenever you see parallel lines like that, think inconsistent and no solution. Okay? So we can look at this, look at your table, and you can tell, okay, that's inconsistent. Now, and if it is independent or dependent, it's neither. It's a no solution. Okay? So you would write no solution.
Wait, isn't it no solution because it's like negatives?
It's no solution because it has no intersection. There's no solution because these lines are not crossing at once. They're not meeting at one point. There's no solution. Okay, use a graph to determine whether the system is consistent or inconsistent, and if it is independent or dependent. Now, is it consistent or inconsistent? Consistent. Good. And it is independent. Okay? All you have to do is look at your table, what you drew, okay, in your notes of vocabulary. Look at it and say, okay, match it up. Okay, that's going to be consistent. Yeah, it'd be the first one. Yeah. Anytime they intersect like that at one point, that means they're inconsistent. Okay? I mean, consistent and independent, I'm sorry.